I'm really great to have the opportunity to be speaking here. Thanks a lot to the organizers, and thanks all of you for being here. So I'd like to start by maybe just like getting a feel for the audience. So who had heard of wit.ai before coming to the conference here? So please raise your hand if you had. Wow, great, that's a lot of people. Cool. So for anyone who doesn't know, the mission of wit.ai is to help everyone build bots that are truly conversational. That means they're able to handle a lot of different conversations. They feel natural, and they can handle actual dialogues between users and bots with like multiple interactions. It's not just like one question, one answer. So that's a pretty difficult problem. And I want to start by first, we can ask ourselves, why is building this kind of conversational AI so hard? So when you think about all the tools that have been invented by humans so far, every time the purpose is usually very obvious and straightforward. So if you look at a hammer, I see that, I know that I'm going to be able to use it to drive a nail, and there's only one possible use case. If I consider a computer, there's like this desktop, like graphical interface. I have a bunch of icons, but every icon corresponds to like basically one feature, and so the whole thing still remains very, very intuitive. And even if I don't talk, just about tools. If I consider, interactions between humans, usually, I have some context. So I go to a coffee shop. If there is a barista, I expect that I'm going to be able to ask for a coffee. With bots, it's often very, very different. So the thing is, the scope of possibilities is very large, and it's very hard to set expectations correctly. I mean, the mistake that I see very often when I use a bot is like, you're going to have some bots that are going to introduce themselves. It's going to be like, hi, what can I do for you? And the user is like, well, I don't know, you tell me. Because I don't know, I don't have any context. And so then people are going to build their bots, and so the bot are going to try to explain every single thing they can do. And so you're going to have this kind of list-like things where you can say, so you can ask me this or that or that, and then I give a reply, and then I get kind of like the next menu in some sense, and the bot's going to have to be to explain every single thing. But that's not how actual conversations happen usually. And the question is there a way that we can make bots that look, a little bit more natural and not just like glorified menus? Because that's what many people have been trying to do, in the past decades. And since the beginning, the approach has generally been to build what we call rule-based systems. So basically, you look at what your use case is, and you just give instructions to your bot. You're going to say, if the user does this, then you should do that. And then you're going to have things like AI/ML, so like specification languages where you write some XML and you have very strict rules. And then you can use some like pattern matching and regular expressions and things like that. And you're going to be able to handle more and more features. And when you do that, the way you think about your bot is usually through some kind of like flow chart. So you have like a bunch of states, and you're going to have some arrows between those states. So if you make something that's like a bot for ordering coffee, so you're going to imagine, okay, my user is going to say something like, I want a coffee. And then the bot is going to say, if there are options, the bot's going to say small or large. And if the user says small, then you're going to serve a small coffee. If the user says large, you're going to serve a large coffee. But of course, in real life, users can say many more things, because the point of having a conversational interface is that you want to allow more flexibility. And so users may say things like, I don't know. And so you're going to have to, go back to your code and add more logic. And you're going to have typically some kind of a catchall state where you say, sorry, you must specify a size in that case, and then go back to a previous state in your graph. And then, as the user could say, there are many more reasonable things you could say. You can say, what's the price difference between small and large? How much larger is large? Or even if you have more features in your bot, user could say, they could change their mind. They could say, actually, you can have a T instead. So you're going to add more and more states. And every time you add a new state, you're going to have to consider how that new state relates to all the other ones in your graph. And generally, you're going to realize that users can just, they don't want to follow your errors. They can give all the information required in a different order than what you expected. They can change their mind, do all sorts of crazy things. And so what is at the beginning a nice, tidy graph becomes a giant hairball that's very hard to manage. But the thing is, that's not even the only use case. The only problem, sorry. Because if you zoom in, even if you don't have any state, if you just consider one simple interaction, you still have that core issue of understanding what the user is trying to say. So natural language understanding is hard. If I do something as simple as like a weather bot, for example, the user could say, how is the weather today? What's the weather today? What's the forecast? Or something like that. So you're going to have to handle all those different variations. And when you have things like, typically like dates and times, if you have a bot that says, when should I set your appointment? The user could say, in a fortnight, or first Monday of next month. And you're going to have to handle all those things. And this is really non-trivial. So typically the way this is solved today with most bots is by putting constraints on the interface. So like a typical thing you can do is you can actually show buttons, because you can do that with your interface. And so you can just show the different choices. If it's things like dates, you can show a date picker. And that's basically you're kind of putting the burden on the user. That's not truly conversational yet. And the question is there a way that we can do better than that? Because there is, on one side, so businesses today, they have very specific and narrow use cases, and they want to find the best thing that works right now. And then you have the crazy stuff in the movies, like 2001 Space Odyssey or Her and that kind of thing. And that's what some people dream of when they think about bots. And you have this huge gap. And the question is there any way we can move towards having more advanced bot and start bridging that gap a little bit? And if we tried to do that, how would that look like? So at WIT, that's a problem we've been thinking about since 2013. And so our first goal was to try to make what the existing technologies in natural language understanding available to everyone. So when we started so back then, the idea is that there was already a lot of technology out there, but many people were not aware of it, or they were not using it because it was too difficult. So we just started, at the time, so the world has changed a lot since then. At the time, having a .ai domain name was thought about as being original. Things have changed today, obviously. And so at the time, we were focusing, on the basics, which is sentence-level natural language understanding. So the idea is you're going to receive a sentence in natural language, and you're going to try to extract as much information from it as possible. So you extract those kind of entities. And so the way it would look like was something like you would say, set the temperature to 70 degrees in my bedroom, and WIT would extract bedroom, so the room, and 70 degrees, the temperature. And so your application gets back some nice JSON data that is very, very easy to use. And that worked really well. We were just using traditional machine learning algorithms, like linear classifiers and conditional random fields for the experts in the room. But we really tailored them for bots. We wanted them to work for those specific, the bot-specific use cases. And we wanted them to work with very small amounts of data at first, because when you get started, when you have your new use case, you don't have anything. So we wanted them to work with small amounts of data and then be able to scale a lot when you have many more users, and the bots can become more and more robust over time. So some components, so we decided to open source some of the stuff that we had. For example, we built this probabilistic parser that we call Duckling. So you can give it expressions like next Monday at 9 a.m. and it's able to really parse the complete expression and output an actual timestamp that your application can use directly. And if you test it, and you can go to duckling.wit.ai, it's actually able to handle a wide range of different kind of expressions. And so it's not just dates. You can do currencies and a whole lot of other things. So far, everything is completely stateless. So this is really great for applications typically in like Internet of Things kind of space. So you're going to say things like open the garage door and turn on the lights. Perfect for that use case. The thing is, as soon as you start having any kind of state, it has to be managed by the developer. So that means you have to solve this problem. As I said, it's pretty hard as soon as your bot becomes non-trivial and starts doing more than just a few things. So at this point, we kind of went back to the drawing board a little bit. And we thought a little bit about whether there's any way we can help developers do that. So yeah, so we think that the answer is yes, but it will require a shift in the way that people think about building their programs. If I take a very simple example, like converting Fahrenheit degrees to Celsius, so it's a very, very, very simple problem. So typically, what you will do with traditional programming, you're just going to subtract 32 and multiply by 5 and divide by 9, and you're done. If you want to do something that looks a little bit more AI-like, what you would do is you would just come up with a bunch of examples of conversions and feed them to the machine. And then you're going to have some kind of generic algorithm, so like a black box that's going to learn from those examples and kind of infer the formula. That would be a completely stupid way to solve this particular problem, because you have the formula already. But for other problems, like recognizing objects in images, like recognizing that there's a person, a dog, and 2 chairs in that picture, then many people have tried for a very long time to write a very complicated program with lots of different rules and hacks that you put together to try to make something that kind of works in some cases. And then what happened is that people realized that actually the best way is just to have a whole bunch of different images that are labeled by humans. And then you have a general algorithm that learns from that data. And then you get results that are far better than what you would get if you used the like old school traditional programming approach. And so our line of thought was, if we're going to make bots that feel natural, we're going to have to get a little bit closer to the way of programming that you have on the right. So we tried to reimagine what the development workflow could be like, and the concept we came up with is called stories. So what a story is, it's a description of a conversation that is going to happen between your user and your bot. It is just, it's purely declarative. You just say what you want to happen. You don't say exactly how it's going to happen. In other words, your stories are examples of conversations and not actual rules. You're not trying to specify the logic and how the bot will work. So an example of story, to make things a little bit more concrete, could be that. So for a weather bot, the user would ask, what's the weather? And the bot could reply, in which location? Then the user could say, I'm in Vienna, at which point the bot can fetch the weather for that location and then give the forecast back to the user. So of course, I mean, that's the easy case. There are many other things that could happen. I mean, the user could reply incorrectly, or give an invalid location, or fetching the weather could fail. So the idea is you're going to have several stories. So you're going to have one story and then test your bot and then identify how it fails and add different stories to try to make your bot more complete. And once you have a bunch of different stories, so the platform, in this case wit.ai, is going to take all your stories and ingest them and build a coherent model that supports all the use cases that you have specified so far. So at that point, you may ask, why exactly would you want to do it this way? Isn't it a little bit like the graph that I showed you before, except that you're just specifying it in a different way? So the answer is for simple bots. So if you have 10 stories or so, it's actually going to be pretty much the same thing. It's going to be pretty much like a graph, like rules. And that's OK, because if your bot is very simple, that's exactly what you want to happen. You say, you give a given story, and you want just that to happen. The thing is, if you have many different use cases, if you start having several dozens of stories, your old like graph-based approach is going to become not manageable. Actually, you will need your bot to become a little bit smarter to handle failure modes like the user changing their mind or specifying information in different orders and things that you didn't expect. For example, in the weather case, if the user says, "What's the weather in Vienna?" It would be nice if the bot was able to directly jump to the end of the conversation and not like ask what the location, because you already have the location. Or in the coffee example, you have one story about coffee and maybe another one about tea, and maybe you would like your bot to recognize that if the user changed their mind, you're going to have to switch to another story. So those stories will be treated more as heuristics. So the way that's going to happen is you're going to have on one side your declaration, what is the high-level behavior of your bot, and then there's going to be a model, so a learning algorithm that's going to ingest all your stories and build a coherent bot that is compatible with all the stories that you specified so far. So the cool thing is that the idea is you want your declaration to be completely decoupled from your model. Why do you want that? Because maybe your use case is clear today, so you can actually specify your story, but the idea is that all the learning algorithms that I mentioned, there's a ton of research being done today. And it's going to evolve a lot in the next few years. And the model is going to change. So you want to be able to reuse the work that you've done to create your bot with the progress that will be made over the next few years. So that's why we chose to build things this way. And the last point is that if you do it this way with individual stories, it's more easily extensible. If you want to add new features, you just add one new story. You don't really have to look back into like all your previous stories. You just create a new one. If you had a graph, it would be more like you would need to come up with like a new state and find a good place to put in your graph and see how it relates to all the other states. Even if you're not making the graph explicitly, that's what you're going to have to do when you're writing your code. So, of course, sometimes having just like purely linear stories might not be the most intuitive thing to do. So for simple things like the coffee ordering, we still allow you to have a notion of branching, so you can like handle small and large in the same story. And you may have some common logic, like an order confirmation flow. So we'll still allow you to do some things like jumping to another story that you've defined somewhere else. But the important thing to remember is that this is still declarative. This is not like a contract as to what's going to happen exactly, and the model is going to try to be smarter and handle, like generalize given the stories that you've given to it. So something that I haven't talked about yet is, you have this model for your bot, which is like kind of abstract, and then you have your concrete business logic. So for a weather bot, you actually need to go and implement, how like fetching the weather is going to work, for example. So the way we do it is through something called the context, which is kind of like the common language. So your individual actions, so the bot is not going to know exactly what your individual actions are doing, but the contract is that an action is something that will take the context, do something, and return an updated context. And that's how the code that is specific to your use case, your business logic, is going to interact with the conversational model of your bot. So now that we have this, the new workflow is to, when you have a new, you want to create a new bot, is to start with the simplest use case that you can think about, which is called like the happy path, and you just make one story for it. And then the platform allows you to immediately start using your bot. So you get some immediate feedback. You can just try your bot and see how it fails, basically. And for each failure that you identify, you can add more stories to refine your specification and add new features over time. Now, the cool thing is that every time you add a new story, we're going to retrain a new model for your bot. And what we're going to do is we're going to run all your existing stories against your model, and we can immediately identify if your different stories have conflicts with each other. And so you can see which one of your stories are okay, and if there is a problem somewhere, we can directly point you to where the problem is and how to fix it. So we want you to be able to only specify the minimum amount of information that is required to make your bot. That's how the workflow looks like. And at some point, when your bot becomes complex enough and you have some good feature coverage, you also want to let users interact with your bot and kind of tell you what are the things that they expect and that you're not supporting yet. So you can look at what they're doing, and if there are some conversations that go well, you can just validate them and add to your data set of examples of conversations. You can create new stories automatically. And if something went wrong, you can fix the stuff that wasn't quite correctly handled by the bot and make a new story for that as well. So we're still building that a little bit. So we have most of the functionality there. We want to add more complete support for stories. And the last point is that we think it's also important for you, once you have invested a lot of time in creating your bot, to actually be able to export all your specification. I said that we're going to make the model evolve over time, so that's really cool if you can actually take the declaration that you have and test it with a bunch, maybe other platforms, if other platforms ever implement similar models. So the idea is you can export your instance in a human-readable text format, and then you can, so that specification contains everything in your specification, like what your stories are, what kind of entities you're extracting, what are the definitions of your actions of in your bot. And then you can work as a team. You can put this in version control, work on it as a team, and then import a new version when you're done and push the new version of the bot to your developers. So we really tried, and we're still trying to make all the new features as community-oriented as possible, because we noticed that since the beginning, this has really helped us a lot. All the built-in entities, like the common stuff for dates and times and locations and names, for example, they really leverage the fact that there are many apps on the platform, and so we can have very good recognition for them. So that's the importance of the community. As a developer, you can also explore the existing apps on the platform, because you can choose to make some people choose to make their apps public. And so you can explore them, you can fork whatever you like, and then adapt it. So it's kind of like a GitHub-like model. And as I said, we try to open source as many libraries as possible, and we already have amazing people from the community contribute back support for new languages and entity types and that kind of stuff. But there's much more to do. Things we'd like to have are things like library of API integrations, so you don't have to code everything again when you get started. Something a little bit different is like common conversational modules. So there are many use cases out there that kind of need similar flows for payment and delivery, for example. So that's on our radar as well. And also, when you want to make your bot speak, today the simplest way to do is to just use simple templates. But also you can have your custom logic if you want, of course. But in the future, we'd like to have more advanced language generation. Right now, we focused more on the language parsing, but you can have better language generation to make the whole thing feel a little bit more natural over time. And of course, analytics to make so you can really get a precise picture of how people are using your bot. And there are a lot of other things as well. And the idea is if we do all of that, hopefully we'll be able to have bots that look a lot more natural, that are closer to what people think of when they think about actual AI. The thing is, we need to be prepared for the fact that, as John McCarthy said, as soon as it works, no one will call it AI anymore, because it will be part of the everyday life. Thank you very much.